feet from the meter to the farthest most remote outlet. I don't know which one of those it is, I don't care. Because that's my distance, 95 feet. Is there a 95 feet on your chart? No. So you have to go to the next highest number, which is 100. So I'm gonna be on the 100-foot row. 100 foot. Now, I started off with 50 PSI. That was my lowest pressure available. But my elevation difference from the meter to the highest fixture in the house, which would probably be the connection at the water heater, or maybe the shower valve, probably the water heater. The distance in elevation is 25 feet. What's half of 25?
12.5.
12.5. So I'm gonna subtract 12.5 from 50. And that's gonna give me my pressure. 50 minus 12.5 is 37.5 PSI. So I'm gonna be on the top chart. The top chart is 30 to 45 pounds. Now, I'm gonna total up all of my fixture units. I have 2 water closets that are 2.5 each. That's 5. I have 1 tub, that's 4. I have 1 shower, that's 2. I have 3 lavatories at 1 each, that's 3. I have 1 kitchen sink, which is 1.5, 1 silcock or hose bib, which is 2.5. I have 1 clothes washer, which is 4, and I don't have a bar sink or a laundry sink or a dishwasher. So I'm gonna total all of these up. I have 2.5s, that's 1. 6, 10, 12, 15, 16, 18, 22. I have a total of 22. So right here, I'm gonna write total fixture units 22. Is there any questions so far? Everybody still following me? Okay. All right. Water closet, 2.5. Lab is 1. Shower's 2. Tub is 4. Lab is 1. Water closet, 2.5. Silcock, 2.5. Clothes washer, 4. Kitchen sink, 1.5. Okay. Now I'm going to go back to my chart. Right here. And I'm going to look at the very top chart. I'm on the 100-foot row, and I'm going to go down and look for 22 fixture units. I don't see 22, I got a 21, so I got to go to the next highest number, which is 25. And I'm going to look all the way to the left. That's a 1-inch meter and a 1-inch service. This is my meter. This is my building supply and branches. So I have a 1-inch meter and a 1-inch service. We'll do that right here. 1 inch, 1 inch. Is there any question? Okay, now pay attention to this part. I'm looking right here on the 100-foot row. This is my building supply and branches. And it says that on 1/2-inch pipe at 100 foot, I can have 3 fixture units on 1/2-inch pipe. And I can have 12 fixture units on 3/4 pipe. And I can have 21 or 25 on 1 inch. Because I have a 1-inch meter, I can have 25 on 1 inch. So I'm gonna write right here, 1/2, 3, 3/4, 12, 1 inch, 25. That's how many fixture units I can have on that diameter pipe. Is there any questions at all? Okay. I don't need this chart anymore. I have all the information I need off of this chart right here. So I'm just gonna leave it right there for a minute. Now, I can go ahead and start the sizing. So I'm gonna start up here. It doesn't matter if I start here or here. It doesn't matter. So I'm gonna start at the water closet. The water closet is 2.5 fixture units. And I can have up to 3 on 1/2-inch. So this piece of pipe is 1/2 inch going up to the water closet. Is there any question?
So you're.
Are you lost?
No, you start the smallest, furthest from.
I start away from the meter and work because I have to add them as I go. Okay. The lavatory is only 1. That's less than 3. So the lavatory is 1/2 inch. You're just gonna have to wait clean. Okay. But now I have a T, which means this piece of pipe is supplying water to both of these fixtures, right? Is there any question? This piece of pipe is supplying water to both of these fixtures. So I have to add the fixture units together. And I get 3.5. Well, that's more than 3. So I gotta go to the next highest number. This piece of pipe is going to be 3/4. Is there any question? Okay. The shower is 2. That's less than 3. So the shower will be 1/2 inch. And that's going to be 1/2 inch all the way around the corner. Both of those pieces. Okay? Because that is the supply to that fixture. Even though it's 2 pieces, it's 1/2 inch. The lavatory is 1. The lavatory is 1/2 inch. And then I have another T. This piece of pipe is supplying the water to both of these fixtures. So I have to add these together. And I get 3. That's 1/2 inch pipe. Barely, but it's still 1/2 inch pipe. Is there any questions? Make a little more sense? Okay. Now I have another T. This piece of pipe is supplying water to all 4 fixtures. So I've got to add this and this together. And I get 6.5, which is more than 3, but still less than 12. So it's gonna be 3/4. Any questions? Okay. Now I have another branch. The kitchen sink is 1.5. That's less than 3. So the kitchen sink is 1/2 inch. Then I have a clothes washer, which is 4. That's more than 3. That means I have to take 3/4 pipe to the clothes washer because of my distance, my low pressure, and my elevation. So this is 3/4. Then I have a T. So I have to add these two together and get 5.5, which is more than 3, but less than 12. So this piece is 3/4. Any questions?
I got one question.
Yep.
How did you figure out the pressure before the house is there and everything?
Well, you can either put a gauge at the meter,
What if the meter's not there?
then you can contact the city and find out what their peak demand is and their overnight pressures are. Because they're supposed to have a tally on what it is in each neighborhood and check the pressure on
But
different
the
neighborhoods.
pressure matters at the meter, right?
Yes,
In order to do the site.
technically yes. So if you don't have a meter, you can get like a 1-inch jumper and put a reducer on it with a gauge on it, crack it open just long enough to get some pressure and check the pressure at the meter. Because that's basically just a 1-inch thread for a 3/4 meter. It's gonna be 1-inch threads. A 1-inch meter is gonna be 1.25 inch threads. It's gonna be the next size higher, maybe 1.5 inches. I don't know. But you'll be able to jerry rig something together and make up a little gauge rig to hook up to the curb stop and just tighten that nut onto the nipple and then turn it on long enough to keep your pressure. You can get that. Okay. Now I have another T. This piece of pipe is supplying water to everything. So I gotta add the 5.5 and the 6.5 and I get 12, which is still 3/4, barely, but it's still 3/4. So this piece is 3/4. Any questions? Think I saw a light bulb go off. Branch. Gonna start over here at the tub. The tub is 4. That's more than 3. So the tub is 3/4. And that's 3/4 all the way around the corner. The lavatory is 1. That's half. And then I have a T. So this piece of pipe is supplying water to both fixtures. So I gotta add the 1 and the 4, and I get a 5, which is more than 3, less than 12. So this piece of pipe is 3/4. The water closet is 2.5. That's 1/2 inch, less than 3. Then I have another T. I have to add the 2.5 and the 5 together, and I get 7.5, which is more than 3 but less than 12. So this piece of pipe is 3/4. The silcock is 2.5, that's less than 3. So this piece of pipe is 1/2 inch. And then I have another T. So I have to add this and this and I get 10. That's more than 3, but less than 12. So this piece is also 3/4. And then I have another T. This piece of pipe is supplying water to everything. So I add my 10 and my 12, and I get 22. Well, I know I did my math right. 22 is more than 12, but less than 25. So this piece of pipe will be 1 inch. And that's how you size the cold. But now, I have one going to the water heater. So I have to add up my hot fixture unit values. And here's the easiest way I've found to do this. When you're sizing, I highly recommend doing this on a piece of scratch paper. Highly recommend. Watch how easy it is to do the hot. Does a water closet have hot water?
Nope.
The tub, shower, lab, kitchen. What about a silk hot?
Nope.
Clothes washer?
Yep.
Okay. So I started off with 22, and I'm gonna subtract 7.5. That's 14.5. What is the deal with all my reds? Guess I'll have to use hot pink. That's how many fixture units I have on the hot side. That's more than 12. So I have to take 1 inch to my water heater. And that's it. That's the sizing for that house right there. We're done. Now, I do have to say this to every plumber in here. If you're in the real world, you're sizing a building and it calls for 1 inch to the water heater. You have to take 1 inch to a 1 inch input water heater, like a 65-gallon water heater. You can't reduce it at the size of you can't reduce it down at the heater. It's gotta stay 1 inch into the heater and 1 inch out of the heater to feed that house. It needs that size pipe. The only way to get around that is to come out of the wall with 1 inch and put 2 smaller heaters, like 2 40 gallons, and bullhead a 3/4 by 1 T and run them parallel from the hot and the cold to 2 smaller heaters. But you have to take 1 inch to and from the heater if it calls for 1 inch, because it needs that volume to feed that many fixtures.
Is there an exception for tankless?